CNC cutting parameters explained, how to choose the correct spindle speed, feed rate, and cutting depth. No matter how expensive your CNC router is, no matter how powerful your spindle may be, and no matter how premium your cutting tools are, none of that guarantees perfect machining results. The secret behind clean cuts, long tool life, and high productivity lies in something many beginners overlook: cutting parameters. Incorrect settings can cause burning, vibration, poor edge quality, broken tools, excessive machine wear, and wasted material. Correct settings allow your machine to work faster, more accurately, and more efficiently while producing a better surface finish and extending the life of your router bits. In this video, we'll explain the most important CNC cutting parameters, how they interact with one another, and how you can optimize them for different woodworking materials. By the end of this video, you'll understand why experienced CNC operators spend so much time perfecting their machining settings. What are CNC cutting parameters? Cutting parameters are the values that control how your CNC router removes material. The most important ones include spindle speed, RPM, feed rate, plunge rate, cutting depth, step over, chip load. Every successful machining operation depends on balancing these parameters correctly. Changing just one value affects all the others. That's why experienced CNC programmers always think of cutting parameters as a complete system rather than individual settings. Understanding spindle speed. Spindle speed is measured in revolutions per minute, or RPM. It determines how fast the cutting tool rotates. Most woodworking CNC routers operate between 6,000 and 24,000 RPM. A higher RPM does not automatically produce better results. If the spindle rotates too fast while the feed rate remains too slow, the cutting edge begins rubbing instead of cutting. This creates excessive heat, burns the wood, and dramatically shortens tool life. Finding the correct spindle speed is one of the most important parts of CNC programming. Feed rate explained. Feed rate is the speed at which the CNC machine moves the cutting tool through the material. It is usually measured in millimeters per minute. A feed rate that is too slow causes excessive heat buildup. A feed rate that is too high can overload the cutter, increase vibration, and produce poor surface quality. The ideal feed rate allows the cutter to remove material efficiently while maintaining smooth motion and stable cutting forces. Plunge rate. Plunge rate controls how quickly the cutting tool enters the material vertically. Because the cutter has less room to evacuate chips during vertical movement, plunge rates are usually much slower than horizontal feed rates. Reducing plunge speed helps protect the cutting edges and prevents unnecessary stress on the spindle. Cutting depth. Cutting depth describes how much material is removed during a single machining pass. Shallow cuts generally produce excellent surface quality but increase machining time. Deep cuts improve productivity but require more spindle power, stronger machine rigidity, and carefully selected feed rates. Professional workshops always try to balance cutting depth with machining efficiency. Chip load. Chip load is one of the most misunderstood CNC concepts. It represents the thickness of the chip removed by each cutting edge during one revolution. Too little chip load means the cutter rubs the material instead of cutting it. This creates friction, excessive heat, and rapid tool wear. Too much chip load increases cutting forces and may break the tool. Finding the proper chip load is essential for both productivity and tool life. How these parameters work together. One of the biggest mistakes beginners make is changing only one parameter. Imagine increasing spindle speed while keeping the same feed rate. The cutter now removes a much smaller chip. Instead of cutting efficiently, it begins polishing the wood. Heat rises dramatically. The opposite happens if feed rate increases without adjusting spindle speed. Cutting forces become excessive. Professional CNC operators always adjust spindle speed, feed rate, chip load, and cutting depth together. Recommended settings for common woodworking materials. Different materials require different machining strategies. Softwood usually allows higher feed rates. Hardwood often requires lower spindle speeds and smaller cutting depths. MDF machines vary consistently but produces a large amount of fine dust. Melamine-coated particle board benefits from compression bits and carefully optimized feed rates to minimize chipping. Plywood requires special attention because its alternating grain directions can increase tear-out if parameters are incorrect. Learning the characteristics of each material is just as important as learning the machine itself. Common mistakes. Many machining problems have surprisingly simple causes. Burn marks often indicate feed rates that are too slow. Rough surfaces may result from dull cutters or excessive vibration. Broken bits frequently occur because cutting depth is too aggressive. Poor chip evacuation increases heat and reduces machining quality. Instead of blaming the machine, experienced operators first evaluate their cutting parameters. Building your own parameter database. One of the smartest habits any CNC operator can develop is recording successful machining settings. Keep notes for every material, every cutter diameter, every spindle speed, and every feed rate. After several months, you'll have your own optimized database. Instead of guessing, you'll simply select proven settings that consistently deliver excellent results. This personal knowledge often becomes one of the most valuable assets in any professional woodworking business. Final thoughts. Perfect CNC machining isn't achieved through luck. It's the result of understanding how spindle speed, feed rate, chip load, cutting depth, and tool geometry work together. Every workshop, every machine, every cutter, and every material behaves a little differently. The goal isn't to memorize one perfect number. The goal is to understand the relationships between the parameters so you can make intelligent adjustments whenever conditions change. Mastering cutting parameters is one of the biggest steps toward faster production, longer tool life, better surface quality, and higher profitability. The more you experiment, measure, and refine your settings, the closer your CNC router comes to reaching its full potential.